So welcome back, everyone. This week, we're going to learn about terminology that refers to sampling. So population, sample, sampling frame, sampling era, like different types of sampling, cluster sampling, random sampling, non-random sampling, convenience sampling. So I love this part of the course because although people may feel, oh, this terminology is a bit dry, we need to really understand this, because when we read an article or we create a study, we have to make sure that we're using the right phrasing to explain the sample, and also that the author we're reading is using the right terminology. And like everything else we've discussed, each sampling technique has an appropriate use, and each sampling technique has some advantage, and each sampling technique also has a disadvantage or something that we have to think about. And we'll talk about types of error. So accepting a finding when it's not true, or failing to recognize a finding that is true. And these have implications for us if we work in the field as practitioners. If we follow a study and they make a type of error where they accept that something that's true that isn't, it affects the people we work with and how we use their results. So I know it's a bit clunky in terms of a lot of jargon and a lot of understanding of how to do these various sampling techniques, but you'll see the utility of it as we move through the course. So let's begin. So the sample and population all relate to who's being studied. And my colleague shared these photos with me, but it's the group that you're studying. So is it children? Here's people who are firefighters. We have older adults. We have people in medical community. And I think we have some people, I don't know what they're doing, maybe watching a game or at a party, right? But carefully defining your sample is important. And you really need to explain who will be studied, what will you include, what will you exclude in the group that you're studying. So this is just a silly intro. What formally is the population? The population is the totality, so the total group that you wish to study. It can be all children, aged 5 to 17 in Maryland. It could be all patients in my clinical practice. It could be all administrators in every hospital in our healthcare system. It's the largest group, and this is the group that you will draw a sample from and you will refer back. So the population is the largest element that we're talking about. How do you get from population to sample? You're going to reduce the amount of people that you have in your study. You can't feasibly, talk to every child in Maryland that's aged 5 to 17, or every hospital administrator in a system that's, global. So you need to have some mechanism to pull a subset of your population, your target population, and that's what we call your sampling frame. So what you would do is get a list of everybody that meets your criteria. So here you would get a list of all children ages 5 to 17 in Maryland attending public schools. If you were looking to get a sampling frame for your clinical practice, you would need to make sure that you have every single person, patient or client that's on your list. So those who are no longer in your practice need to be excluded, and the new people who join have to be included on that list. It's really important that the sampling frame is thorough and exhaustive and has everybody. And then we go from the population, we use the sampling frame to get to this lower level, but this is the level that we actually work with. This is your sample. So who are the people that you're working with? And who are the people you're going to ask to participate in your study? So we began with all children in Maryland, 5 to 17. We narrowed it down and looked at public schools, and then we further refined the sample. That this is the strategy we use, random selection, but we narrowed down the sample from this larger group to just 25 elementary, 25 middle, and 25 high schools. So it's a large group, but it's a much more truncated or shorter group than all of the students who meet this age range in Maryland. And then you have, so we went from the initial group, which was your population. Then we had a sampling frame. Then we had a sample population. Then we went to the study population, and these are those that actually take part in the study. So not everybody in your sample will consent to be in your study. So of all those children in the 25 high schools, the 25 elementary schools, and the 25 middle schools, the parents have to give consent. So not all of those children in those schools will participate. So think of the flow, right? Your population, your sampling frame, you have your, oh, and I'll show you here. So you have your population, the group that you're interested in, then you reduce with the sampling frame to the sample population, and then who actually are eligible and participate are your study population. So it's a way of narrowing down reasonably, just like you narrow down your research question, how many people you can have in your sample. And how do you decide who's in that final sample? You have to figure that out, and there are many, many things to consider. So you might want to say, you know, I only want people from this specific county, or I only want people with this specific gender identity or age, or I only want to look at people with this level of disease or diagnosis, or I want to look at hospital administrators that have at least 5 to 10 years of experience in the field. So you're deciding who is your ideal sample. You also have to say who you would exclude. So these are things that if a person says, yes, I have this, or this characteristic identifies me, you might not want to include them. So if you're doing a study about one health condition, let's say diabetes, you may want to exclude people who have chronic kidney disease, or you may want to exclude people who have heart issues, right? Cardiac issues. If you are only able to speak one language and your study team only are monolingual, you may want to exclude people who speak other languages. Again, there are limitations to this, but you have to think about how you can conduct your study. You may want to screen for cognitive ability, and that's throughout life, right? You may want people to take some sort of memory test or some sort of cognitive screener to make sure they don't have delirium, dementia, or maybe even depression. So you decide what you're looking for in your sample, and you make inclusion and exclusion criteria, so you just get the people that meet them. And I'll give you an example, right? It's age-based. I'm a gerontologist, right? So bear with me. Let's say that, you know, I decide I want to study older adults in assisted living situations, and I want to look at their satisfaction and quality of life, right? Assisted living are not skilled. Assisted living, people get help with instrumental activities of daily life, right? And maybe some cooking, some cleaning, right? They may need some support, but it's not a skilled nursing care facility, right? So it's a place where people live with some care. So what are my inclusion criteria? I want to say that people have to be at least 65 and older. You might say, I want people 80 and older, 75 and older. That's up to you when you design your study. For me, when I was working in New York, I had a geographic limit that they must reside in the state of New York. And you can consider why. When I want to generalize my findings out, I can generalize to states similar to New York. If I have people from various states, I have to think about how I'm going to use those results. And then they have to be living in a facility that is identified as assisted living. And for this study, although I do work with people with Alzheimer's and related dementias and cognitive impairment, for this study, the people could not have severe impairment. So you could have mild cognitive impairment, maybe moderate, but not severe. And that we would use with the screener. There's a bunch of tests we could use with varying success, you know, in terms of application to see who would be screened as eligible. And then sampling is what we do. So we have the population, we have the sampling frame, we have the study population, we have the study sample, the group of people. And then how do you go about selecting them? How do you go about choosing them? We can't pick every single person that is eligible for our sample, because we just don't have the ability in terms of cost and time. And think of the census. The census is a full sampling frame. The census captures ideally every single person who lives in the US, and we'll see there are problems with it, but we can't mount an effort that is going to cover every single person that is eligible for our study. So we have to find a way, a systematic way to reduce the number of people in our sample. With the census, even though the census says it's a complete count, I want you to think about this idea that nothing is perfect, right? There are limitations. So the census misses people a lot of the time, people who are experiencing homelessness, people who are away from their residence, people who are visitors, people who live in many places, students who have multiple residences, right? People who are born on the day of the census, all these kind of things, people who are in prison and other facilities, we miss them. So it's the idea that we want to get a sampling frame that's as thorough as possible, that has every name. Remember, if you're getting people in your clinical practice and you just get 5 new patients today, they also need to be in your sampling frame. So if you use the sampling frame that has your census of patients from yesterday, you're going to miss the people from today, and it's going to affect your the way you kind of pull a sample and introduce error. So you kind of get the gist of this, but I wanted to sum it up again, that the sample is the group that should be drawn from the population and should be similar or represent the population it's drawn from. And then sampling is the way that you choose people for your sample. It's the process that you use. And I hope this is helpful. I think it's a really, someone shared this with me, and I think it's kind of neat, right? So if you're, as a researcher, we'll apply this. So if you're building a bridge, you can't make the full bridge. So you're going to make a smaller model of the bridge, and then you're going to extrapolate the values of that tiny model into the full-size bridge. So it's the same thing with sampling, that what you're going to do is use your sample as your mini bridge, carefully draw it from your population so that it is representative, and then you're going to apply the results from the sample back to the population. That's kind of how we do it. So this is the key question that we have to think about, right? When we're drawing this sample, we want to make sure that it represents the larger population. If our sample, a larger population, I don't know, let's say is 50% people identify as women and 50% of people identify as male. And in our sample, 95% of the sample identify as women, it's not the same, right? So we really want to use a couple strategies to get a sample that represents the population. So we want to make sure that it's randomly selected, and we'll talk about that. It means that there's no underlying bias or order in the way people are selected, that every individual that's could be in your sample has the same chance of being selected. And that's what random selection means. When I spoke before of like 50-50 men and women in the population and 95% in the sample, that's non-representative. We want to make sure that the sample, if we look at it like that bridge, it's a tiny model of what the population would be. And if we assure that we randomly select participants and that our sample is representative of the population, we can generalize findings. So we can have we can generalize information from our sample and what we found in our study to populations of people that are similar. So if you were looking at an OT practice with children, in a suburban setting, and you draw that sample randomly and it's representative, you can relate it back to maybe a county that's suburban in the same state that has a similar practice, right? So we always say, random selection, being representative really help with generalization. Right, and you may say, okay, you gave us an example of random selection, but was pretty quick. So let me break it down that when you're using random selection, it means that every person or every possible patient, client, hospital, whatever that unit of analysis is, that it has the same chance of being chosen, right? There's no bias in it. And we'll talk about this a little bit later with the confidence interval, but we want to make sure that when we draw the sample from the population, that their statistics are similar and they're confident that their confidence interval is rather narrow. Don't worry about it now. Right now, just think about if we pick a random sample, everyone has the same chance of being selected, and that helps with making sure that our sample looks like the underlying population. Representativeness, this is the example I gave you with gender, but it could be any task. If you're looking at, pick a sample of people who have chronic kidney disease, and in your sample, 5% of people have chronic kidney disease, but in the population, it's 20%, that's not representative. The same percentage or same characteristics of, disease or gender or race or class or income, those items, the demographic items, should also match those in your sample. And again, this is the pairing. The more the sample represents the population, the better we can generalize from that sample and say, this is what we found with our study. Therefore, we can generalize it back to the sample, the population that we drew the sample from. Right? How to do it? It's really simple. I've written some painful steps, I think, but all you would do is say, and you can use SPSS or SAS, or you can get apps and you can get all sorts of ways of doing this. You can do it in Excel, but basically the underlying principle, whether it's you or a machine doing it, is you're going to get the sampling frame. So all of the people that are eligible to be in your sample, you're going to number them. And then after you number them, you're going to use a random numbers table, which would tell you what numbers to pick, or a computerized program that will randomly select your participants. And there are many ways to do it. If you're selecting without replacement, once you remove someone from the sample, they're out. When you have with replacement, it means you can put them back in the sample again. Most people, once they select the sample, it's final and it's done without replacement. And this is what I wanted to show you, that ideally when you draw your sample, which is in the lower part of your screen, it resembles the population. So whatever characteristics you have, do you see the parts of this pie chart are similar? Actually, they're the same. Well, similar. Well, no, there's the same, sorry. And this would be great, because if we find any significant findings with this sample, since the population matches it, we could generalize back from what we learn here to this group. Now, bias, it's not everywhere, but the more complicated your sampling technique, the more that bias can happen, right? So bias happens in a bunch of ways, right? You might think you're using a random selection, numbers generator, and you're not. You might think that the sample is representative of the populations in terms of characteristics, but it may not be. You may have some characteristic over or underrepresented. So again, I'll give you the example of the healthy worker bias. So it's in your book, but it's this idea that you could only select practices or only select groups that have occupational categories that indicate that workers are happy and healthy. Or there's Berkman's bias, that it can go many ways, but that you may sample hospitals or places that have greater percentages of chronic conditions than others. And so sometimes we know, sometimes we don't. We can make an error in the calculation when we're drawing a sample, or, you know, sometimes researchers may consciously choose or want to defy representative sampling because they really want to see one particular hospital or group in the sample, and we can't do that. So here's an example, completely different, non-healthcare related. You're taking a poll, right? So you're doing a survey about attitudes toward gay marriage at one of the national conventions. Can you generalize to the US voting population? Right, what do you think? Right, there's some things to look at. Who are the group that we're interviewing or surveying? Is that group a full sampling frame? And then what's the population we're referring back to? So no, the issues are that every single Republican and Democrat is not present at the convention. Every single Republican and Democrat would not represent the average voting age of the US population. So the sampling frame, the group we would look at, those Republicans and Democrats that are attending conventions, are really a select group. So there's like a selection bias because other people in those groups are not there. So we're selecting from a subset. The sampling frame is not full. A better approach would be to look at a full sampling frame of everyone who's registered as a Republican or everybody who's registered as a Democrat. But think about it, that may have flaws if people change political party, but a better approach would be to get that whole list. Now I'm going to ask you, here we looked and said, right, the question was, can we generalize? No. Now let's look at representativeness. We have coal miners, right? This is near and dear to my heart. My mother's family they were coal miners in Pennsylvania, right? So, and honestly, probably I would say in older generations, more than 95% were male. So 95% of the coal miners in the sampling frame are 95 are male, 5 are female. We want to ask about 10, right? We want to ask 10 coal miners about their attitudes toward the job. We decide we're going to pull a sample of 5 men and 5 women. Right? Can we generalize? You guys get the gist? No. Why not? Because in our population of coal miners, 95 were male, 5 were female. In our sample, it was 50-50. 5 out of 10 were male, 5 out of 10 were female. That does not match up to the statistics or the composition of the original population. So here, this is what the population looks like, right? 95 men, 5 women, and here's the sample. So this does not sync up. What we learned from this group will not be generalizable back to this group, right? This sample is not representative of this group. We would have to have in this group different percentages, right? And then this you've probably seen. We always talk about this. This is a good way of looking at selection bias, right? Like it's really interesting because, you know, people hide behind polls like, oh, a Gallup poll or a poll said this or said that, but the construction of the poll is the most important thing. The construction of the survey and then how you're sampling, these are the most important thing. And I think a lot of times when they report findings, we don't get that. So this was a presidential election. The Chicago Tribune did an incorrect headline. Dewey defeats Truman. It was wrong. This is what happened. The editor looked at the results of a telephone survey, and both survey research was new and a lot of people didn't have phones. So the people they interviewed, you know, on the phone, they called on the phone, happened to be wealthy and have stable addresses. So there was a bias in terms of who they thought was their sampling frame. Their sampling frame was not all potential voters. Their sampling frame was wealthier people who had telephones. So the correct generalization would be that wealthier people with telephones would have voted for Dewey, right? This is the correct representation. This is the correct generalization. Not that the whole country would vote for Dewey, only those within this very specific group, stable addresses, wealthy, and have phones. So there are some times when you really can't get a sampling frame, and we'll talk about it, you know, in the next video as well. But you need to think about, what can I do when my sample is different than my target population? And you can do research, but the big thing is if you're not using a standardized way of pulling a sample, you have to let people know, right? So looking at one county versus the whole country, looking at one practice versus, you know, many practices or many hospitals, and you just have to let people know that you can generalize these results only back to places that are similar, right? So, you know, this happens and it's okay, as long as we, again, define it in limitations. And if you think about it, we often study things we have access to. So when I was a program manager, I often studied my own healthcare system and then sister and brother, right, related healthcare systems that we could study. So in order to account for that, we had to mention that we had that we worked for those healthcare systems, but we also talked about it is a limitation. And we also talked about ways we can generalize it out to our healthcare system and healthcare systems that are similar. So I'll stop this video now. And then what I will do in the next video is talk about probability-based and non-probability-based samples. A lot of what we spoke in this particular video were all probability-based samples based on random selection. In the next video, I'll talk about both probability-based, based on random sampling, and then non-probability-based sampling also. So we'll break it up. We'll give you some more terminology just so we can kind of all talk and use the same ways of speaking about our sample. So I'll talk with you in a bit.